In this example, we're going to solve this linear system by graphing. So we'll notice we have two equations, the first of which is in standard form. So we'll need to first solve for y, or put it in slope-intercept form, y equals mx plus b, so we can more easily find the slope and a starting point, which will be the y-intercept, and then we can graph it. Our second equation is in point-slope form, so we'll first start by grabbing an ordered pair and then using the slope to create more points. So let's start with the first equation, 4x minus 3y equals 6. So we're going to solve for this y right here by first subtracting 4x from both sides in an effort to isolate this y. So negative 3y equals negative 4x plus 6. And again, I kind of snuck this x in before the 6 because really I want it to be in y equals mx plus b form. So I want this x to come before this constant. So when I divide every single term by negative 3, it will finish getting my y all by itself. So y will equal a positive 4/3 x, and then a positive 6 divided by negative 3 is negative 2. So here is the first equation, which was in standard form. We have moved it to slope-intercept form. So the y-intercept is going to be negative 2, so we have the ordered pair 0, negative 2, and we have a slope of positive 4/3. Okay, looking at the second line now, point slope form. So the point I'm going to grab from this will be positive 3, and then positive 2, and that'll be like my starting point. And then my slope here will be 4/3. Well, notice immediately, if you will, that the slope of both lines is 4/3, which will indicate this system will either have two parallel lines or two lines that are exactly the same or coincident. It kind of just depends on where these points ultimately fall on the graph. So let's go ahead and start with the first one. 0, negative 2 will be my starting point, and I'm going to use the slope 4/3, so rise over run, up 4 over 3, up 4 over 3, or of course I can go down 4 and back 3. So there's my first line. Let's go ahead and grab my straight edge here and draw the line in. Okay. There we go. And the second line then is going to start at the ordered pair 3, 2. So 3, 2. All right, here you'll notice. So this line already had this point. So since they had the same slopes, m equals 4/3, if I was to go up 4 and over 3, I would be right back at this point again. Or down 4 and back 3, right here again, and so forth. So you'll notice what happens is that these two lines are the same lines. So if I was to graph it again, I would just be drawing yet another line right on top of this first line. So this linear system then, since it has two lines that are coincident, will have infinite solutions. And what that means is that every single ordered pair that is a solution of the first line is also a solution of the second line. So my solutions will be infinite in number, and if I was to classify this system, it would classify as consistent and dependent.